All right, fellow statisticians, so we're doing normal distributions, example 10, part A. We are told that the SAT is normally distributed. This is for females for the record, but the SAT is normally distributed test scores, all right? And we're told that the mean is 998 and the standard deviation is 202. And the question in part A is basically, what would be the 40th percentile? I want to remind you that would be called percentile 40, and we're supposed to figure out what that score would be. That would be one of these numbers across the bottom. These are scores, aren't they? All right? So, if you're at the 40th percentile, well, wouldn't the mean itself be the 50th percentile? I want to remind you how percentiles work. Percentiles are the percentage of the data that falls below, visually to the left of a particular score. So this would be, by definition, at the 50th percentile, because half the people who take the test would score below 998. That's the 50th. So if you're going to be at the 40th percentile, you would definitely need to be below the mean. And this area here would be the percentage of people that fall below that score. That's what percentiles are. And so if it's going to be the 40th percentile, that area there would need to be 40%. So that's how percentiles work, the percentage of data that falls below to the left of a particular score. So there's our X picture, and I would suggest then that we draw the corresponding standard normal, right? And so we're going to look for Z, and basically same shape. We want what they call a lower tail of 40%, don't we? So, hey table! I got a picture for you of a bell curve with a lower tail of 40%. Table not want middle. Table want middle sliver, not lower tail. Table want middle sliver. Always. This table. All right. So, hopefully again our logic would tell us that if we want a lower tail of 40%, we would want to take the lower half of the bell curve, 50%, subtract that tail to give the middle sliver. So, 50% minus 40% leaves a middle sliver of 10%. 0.10, 0, all right? The extra zeros there again, because the areas in this table, the probabilities that live in the body of this table go to 4 decimal places. So 0.1000, a lot of times I just drop the decimal, think of it as 1,000. I see 0.0987 over here in the table. Sorry, I didn't plan ahead the best. 0.0987 and 0.1026 are the two that surround it. And that 0.0987 would be closer. Subtract real quick. This is, ignore the decimal. This is 13 away. This is 26 away. 13 away. 0987. 987. And that lines up with a z-score of 0.25. 0.25. And if you're going to score below the mean, which is what the 40th percentile will be, you're going to have a negative z-score, aren't you? All right, so here we go now. We've got to translate that z-score back to an actual test score. And how in the world are we going to do that? Remember me? All right, this is how we go back and forth between z-scores and actual x's. So the z-score here of negative 0.25, solve for the test score of x. And again, the mu is 998, the sigma is 202, and ready on the count of 3? 1, 2, 3. It's just algebra. I hate it when he makes that face. Yeah, I know. Oh well. Anyway, come on, face it. You miss me, don't you? Yeah, right. But anyway, 202 altogether now. Over 1! It would cancel here, and that leaves x minus 998. And then over here we need to multiply those with each other. So 202 times negative 0.25 is negative 50.5. And then, of course, we add the 998 over in order to solve for x. She's algebra. All right. Algebra was a prerequisite. I have to be a snob. Anyway, if we add the 998 over, and actually this part of it's just arithmetic, but 947.5 would be the test score that would fall there. All right? Now, I don't care. You could circle this, but percentile 40, let's even put a more specific label on it. 947.5 would be the 40th percentile for that SAT. Okay? So again, just remember that percentiles, when you talk percentiles, you're saying what's the percentage that falls below a particular score, which on this scenario would be to the left of on the bell curve. Yes!